Um, Welcome to my YouTube channel, Tumtare TV. Thank you for watching, and today we're going to learn about heat loss is equal to heat gain under thermophysics. Okay, so the best way to explain this is to understand this scenario of heat loss is equal to heat gain. How are we going to do that? So firstly, you're going to have an hot object right there. Then here you're going to have, let's say you have water. There you have water, water, which is a cold object. The main principle for this topic or this subtopic is that the amount of heat should be equalized when these two objects are mixed together. The amount of heat of these two objects should be equalized when they are mixed together. That's the main concept here. So if you drop this object in this cold water, what will happen that you will be got this amount of heat, which is the amount of quantity of heat this object has, and the quantity of heat this cold water has, you equate them. So firstly, you need to understand that, okay, how do I find the quantity of heat of this object? Firstly, you say that Q, which is represent the quantity of heat, is equals to mass of the object, hot object, specific capacity, heat of the hot object. Say open brackets here. Since this one to be the one losing heat, we'll say that initial temperature minus final temperature. Then you equate it. Remember, heat loss is equal to gain, meaning that there have to be an equilibrium. So equate to the heat, the quantity of heat of the cold water, which will say that the quantity of heat is equal to Q is equal to mass of water, W, specific capacity of water, open bracket, change or delta, change in temperature. How are you going to find the change in temperature? Simply say final temperature of the cold water minus the initial temperature of the cold water, like that. This is the formula. I can simplify this by removing this and this, so it will be like this. Initial minus T final equal to mass like that. This is a general formula of finding what heat loss is equal to heat gain. So here you have understood where this formula comes from and how it's made and how it's formed. This is just quantity of heat of the object losing. This is quantity of heat of the object gaining the heat. At the end of the day, these two need to be what? Equilibrium. That's why it's possible when you touch an hot object, you're able to get burnt. Why? Because what's happening there is that you have to get equal with that hot object. Hence, it burns you, so that it should be equal. Your thumbs or your finger should be equal to that plate you are touching, which is hot. That's why equilibrium will try to take place. So here, after this formula here, you should be able to find any of these quantities among this equation. They can ask you to find the final temperature, they can ask you to find the initial temperature, they can ask you to find the specific capacity of water or specific capacity of a metal. All these, so long as you understand this formula, how it's formed, then you're well and good. A good example, let's look at this question right here. This is the question right here, and it reads: 50 grams of piece of metal at 150 degrees Celsius is placed in 100 grams of water at 25 degrees Celsius. Find the final temperature assuming no heat loss to the surroundings. The specific heat capacity, assuming no heat loss to the surrounding. The specific heat capacity of the metal is 0.385 joules per gram Celsius, and the specific heat capacity of the water is 4.18 joules per gram Celsius. So we need to find the final temperature. Like I said, they can ask you to find one of those quantities. So what you need to do is in the exam, what you need to do is what? Remember the formula and substitute. So firstly, you say data. Correct data. You need to have data needed. So you say data. So data. First of all, we need to identify the object which is losing and the object which is gaining. So if you look at your question here, it says a 50 grams of piece of metal at 150 degrees Celsius is placed in 100 grams of water at 25 degrees Celsius. So if you compare the two temperatures of these two objects, you'll see which one is higher and which one is lower. So if you look at these two objects, the one with the higher temperature is what? It's this cement which has 150 degrees Celsius, meaning that this is the object which is what? Losing heat. Hence, should be on the left side part of the equation, and the water should be on the right part of the equation. So here you say mass of the metal I've been given, which is 50 grams. We need to have what? Specific heat capacity of the metal, which has been given is right here in the question, which is 0.385 joules per grams Celsius. Then we need to have what else? So the specific heat capacity of the metal is 0.385 joules per gram Celsius. Then we need to have what else? The change in temperature, delta theta. Yeah, delta theta, change in temperature, which is the initial temperature of the metal, which is Ti, is equal to. So the initial temperature of the metal is 150 degrees Celsius. Right there. So now we need to find the data for the one which is gaining, which is the water. So now we need to find data for the water which is gaining heat in this case. So the mass of the water have been given is 100 grams. Then the specific heat capacity of water have been given, which is 4.18. Then the initial temperature of the water have been given is initial temperature 25 degrees Celsius. Okay, so right there you have everything which you need to plug in this equation or in this formula. So we need to do that. So get the calculator right there. So we say that mass of the metal represented by M, the capacity of the metal, open bracket, initial temperature minus final temperature, close bracket, equal to mass of the water times specific capacity of water, open bracket, final temperature of water minus initial temperature of the water. Right there. Now just substitute here power of the metal, the mass of the metal, which is 50 grams. The specific heat capacity of the metal is 0.385 close bracket, open bracket, the initial temperature of the metal, which is 150 minus final temperature, which we're looking for. You equate there the mass of water, which is 100 degrees close bracket, the specific heat capacity of water, you plug in the final, we don't know the final temperature, same minus the initial temperature, which is 25 degrees right there. So now simplify by expanding the brackets. So say open brackets 50, open brackets 50, again open bracket 0.385 close bracket to give us 19.25 close open bracket 150 minus final temperature close bracket is equal to 100 times 4.18 close bracket to give us 418 open bracket final temperature minus initial temperature, just like that. Then what do you do next? You continue expanding the brackets by simply saying okay, 19.25 open brackets 150. If you multiply 19.25 times 150, should give us 2887.5 minus, if you multiply this, it will just be negative 19.25. Final temperature is equal to, multiply this to give us 418. Final temperature minus, when you say 418 times 25, should give us 10,450. Then group like terms together by simply saying, okay, the one with the final temperature should go on the other side of the equation, and the one with no variables attached to it should go to other equation. So to be 287.5. When it crosses the equal sign, it becomes positive. It will be 10,450 is equal to 418 TF plus 19.5 TF. Now you have that. Now let's just simplify there by saying, okay, 287 plus 0.5 plus 10,450 to give us this number, which is 13,337.5 is equal to, when you add 418 plus 19.25, it's going to give us 437.25 TF. Then let's divide here by 437.25. On the other side as well, divide by 437.25. You cancel out here, leaving you with final temperature is equal to, when you divide this into this, so simply say 13,337.5 divided by 437.25, which will give us the final temperature will be 30 degrees, 30.5 degrees Celsius. That's how you find the what? That's how you use this scenario or this concept of heat loss is equal to heat gain. Now we can look at the past examination paper for ECZ Physics 54. The question came in 2016 GC, question 5 B2. 2016, question 5 B2 to 2016, this 2017. Okay, 2016 right there. You can see this is ECZ 2018. So 2016, ECZ 2016 GCE. Question 5. Is it question 5? Yeah, question 5 right here. Question 5B. Okay. Let's try to solve it. Applying the knowledge, we have solution. Okay, so I try pass examination question which came in 2016 GCE, question number 5B2. To a 200 grams of water at 48.2 degrees Celsius, 100 grams of cold water was added. Calculate the final temperature of the water. Okay, let's do this. So the first step in it, what to do is correct data. Very important. Always correct data. So say data. What is the data given? What is the data given? Okay, we have 200 grams of water at that temperature, so which is the hot object in this case. The mass of it is what? 200 grams. Then initial temperature is 48.2 Celsius. And we know that the specific capacity of water is the same. Literally, like it's the same. When you do these calculations, it will cancel each other out. They will cancel each other out since they are the same. Like literally, they are the same.